I'm back. What this video is about is to help someone out. They're having troubles with, well, primarily, and it was the radio I used on my last video that's uploading right now. Basically, they're having troubles with this resistor burning or overheating, getting too much wattage. They're getting too much current through here. I commented to them and asked them if they had worked on any or found any problems. They came back and told me that they're showing about 60 milliamps here current, which is double what it should be. So what I wanted to do was to well, first of all, kind of go over basically with the voltages in here what kind of current should be there, and we're going to look at the parts list to prove that's the case, and then we're going to look at some, well, possible reasons. And really at this point they looked over their wiring, because they had to do a lot of rewiring on the radio, because it was one of those radios that has the rubber coated wiring that was going bad, the insulation was, so they had to do a lot of rewiring. And that being said, they thought, well, maybe they did make a wiring mistake, and so they double checked it, went over it and looked through it, and everything seems to be fine, which is, standard procedure. If you're having troubles and you did some wiring work or anything, or no matter what you're doing on a radio, whether it's just recapping or whatever, it's always a good idea. If you start having problems, first thing to check is your work. Now, to answer one of their questions, though, was dealing with the, and I'll try to hold this steady. It's getting late in the day. I've made kind of 3 videos already, so my hand's not the steadiest. So bear with me. Was the tuning condenser, which is right here, and of course it's like most of them mounted on rubber grommets to isolate it from the speaker and from the vibration. And the question was they're deteriorated, and would that possibly allow the condenser itself to short, the frame? And the other question was, could any of the plates possibly bent and cause shorting and cause this problem? Well, first and foremost, the thing I want to point out is the tuning condenser is in the grid circuits. Alright, it's not any B plus plate of any kind, any B plus circuit. It feeds right here, it's across this coil and goes right up to the control grid here for the oscillator, and then this one is just in the antenna circuit going into the control grid for the mixer. And so no matter what's going on with it, the worst case scenario would be if it was completely dead shorted, like with the plates, would be just not get no signal. You wouldn't get no radio stations. As far as the grommets go, they're only there to keep vibration out. It actually has ground straps of some sort that are going from the main body to the chassis, because one side has to be grounded, and this side happens to be the rotor shaft and the main frame. It has to go to ground, so it's okay. The only thing the grommets will do is allow it to be sloppy, and it'll still ground because it's got straps, but it just be loose on the chassis, and that may make it the dial not to, well, at least on some radios the dials will not show properly through the bezel on the front of the chassis or something like that, because it's sitting down low. And the other case would be is now it's going to get affected by vibration, so you replace the grommets to take care of that. So the tuning condenser has nothing to do with this. Now, he was going to go ahead and if you really notice, this is all undotted because this schematic is for two different models. He has the 39.7, which does have the push button switches. The model 39.6 does not. So he was going to go ahead and isolate out the switch, completely disconnect it, and wire it in accordance to the 39.6, which you can see dotted lines like right here, dotted lines right here. You'll notice there's X's. Well, the 39.6 is connected here. The 39.7, though, this connection doesn't exist. It's connected here and comes around and connects over here. 39.7 is not connected, but the 39.6 is connected here. And this suppressor grid going up here on the 39.7 is connected this way. The 39.6 is connected through here. So unless there's some other reasons, like somehow some little problem with the wiring somehow got this mixed up between say the detector side here, or which would eventually go back to ground, you know, like these two got mixed up, would be the only reason that you could get some B plus on there and get a little more current draw. If all wiring, and I assume it is because he checked it, all the wiring is good, then really there's only one probable main culprit that can be doing this. Now before we go over this, I did some figures. I went, looked up in the tube manual for all the tubes that's involved here. You got a 41 output, a 75 type 75 tube, which is a dual diode triode tube, type 78, which is a pentode IF tube, and a 6A7 for a detector oscillator tube, mixer tube, and then of course an 84 rectifier. We don't care about the 84 because it actually does not draw current per se from the circuit, at least not through the means you think it is. So I went through and figured up the voltages. It shows me the voltages 135 and 145 on the 41, 65 on the 75, which is the only one that I couldn't come up with. I had to go real high voltage. I only had one listing. 145 and 75 on the 78, 145, 75, and 145 on the 6A7. Now, using their voltages and getting as close as possible, I went over and wrote down the currents. These are all milliamps. So on the 41 we have the stuff on the left is as close as I can to the voltages that the radio is operating at. So we have 12.5 plus 2.4 milliamps for it. The 75 we got 0.8 milliamps, but that's actually a high voltage, not 65, it's 200 volts on the plate, but that's the only listing they had. The 78, I could come pretty close, so it's basically a total of 5 amps, 4 and 1 milliamp, or milliamps, sorry. 6A7, this is the closest I could get to the voltage showing, and really they're not much difference to higher voltage because they only listed a couple voltages, but 3.5, 2.2, and 4 milliamps respectively. So, and then these over here is the figures for our worst case scenario, the highest voltage and the maximum current draw. At the standard, it's going to be at around 30 milliamps or less. Probably a little less than that, but that's close, and that works out to be a 1/4 watt resistor should work. And actually, when we look at the parts list, you're going to find that they actually list the resistor should be in there as a 1/2 watt, the factory does. Worst case scenario, we're running about 61.1 milliamp, and that's around a 1 watt resistor. Now, to show you something here, I'll thumb down through this to the parts list. Now it's kind of turned sideways, so bear with me. That resistor, by the way, in question is number 24. Shows right here if you can see the little handy. So anyway, we come down here and look up number 24, which is right here. It says resistor 250 ohms, 1/2 watt. That's what the factory put in. That was what was in there, and it burned up. So, short of a wiring error or some other thing that's being kind of strange, like a short in a transformer, that's any transformer, like the IF transformer, transformers, somehow the primary being shorted to ground a little bit. I doubt it, because they're pretty thin wire and they'd quickly burn out. Or the audio output transformer being shorted or leaking to ground enough that it's drawing quite a bit of current. If everything, short of that and all the wiring is correct, then the one problem child that could be causing this is the output tube. Now, when he was playing the radio and I was listening to it, it had a clicking sound. Now, there's various reasons to have that kind of sound, and it depends on, kind of what the sound is. And it's rough regularity and things like that. Now, you can have what is known as motorboating, which really sounds more like a motorboat. I'm not going to get into sound effects, but imagine motorboat sound. More or less a motorboat sound with like a 4-cycle engine. Something like a little twin cylinder or even 4-cylinder 4-cycle 4-stroke engine. That's muffled pretty good. Motorboating is caused by a capacitor being bad. Usually this guy here is usually the one, but if they have a cathode resistor and a bypass, that bypass condenser can also cause it. And so it ain't motorboat. This is more of a click. Something kind of like that. Snap, crackle. Really crack noise. That tends to be, there's other reasons, and I'm not going to go into all the reasons for a noise like that, but one of the reasons is a arc. I've seen output tubes do this. If they get gassy, or they get a speck of something in there that's wanting to arc over and short, or some sort of mechanical damage inside the tube, so the plate can get to, say, like the suppressor grid, or you're close enough to cause this. They'll build up charge and then arc across. Build up charge and arc across. You generally do that in more of a somewhat vacuum state that you can do that. In an atmosphere, you would get a steady arc across. So it'd be more that kind of noise. But in more of a vacuum state, it has to build up. Once it discharges, then it has to build up charge again, and then discharge again, and then you get a real steady, like that. Not saying that's what's going on, but I would be very suspicious of this tube and its socket. You can also get this a little bit sometimes in a socket. The output tube is really the main current carrier. All the rest of the tubes don't carry much current. They're low current tubes, so in order for them to get to any real serious current, like an output tube would have, you would definitely know it, because they'd be glowing like really glowing red. But the output tube is a tube that can draw quite a bit of current. So I would be suspicious of that output tube. It could be gassy, it could have a short in it, the socket could have a problem, a leak across between pins, across the socket. There's a carbon path there. A carbon path can arc and make that noise. So this noise is coming out of the speakers, so that also kind of pinpoints it more to the output tube. There is a slim chance that there is a short to ground, leakage path to ground to the main frame of the transformer, which then is bolted down to the chassis, or I believe on that radio it is bolted to the chassis. In any case, even if it's bolted to the speaker frame, everything's grounded. So if this was having a leak path at one end in this winding, especially the end that's closest wound to it, through the cardboard into there, there's a possibility it could arc and make a clicking sound. So, but 60 milliamps is way too much current draw. I think it's peaking above that, because at 60 milliamps, the 1 watt resistor he put in there, yes, it's going to get warm, but it was starting to discolor real quick. So I think at that point in time it was actually going above 1 watt in order to do that. Because a 1 watt resistor, whatever wattage rating a resistor is, that's where they can run at just fine. They're designed to run at that wattage or less. So if you got a 1 watt resistor, but you're at 60 milliamps is less than 1 watt, it's going to get warm, of course. It's trying to dissipate nearly 1 watt of energy, but it's not going to discolor, and it's not going to start trying to smoke on you or smell on you. That's going to take about double that. So at that point, the thing was trying to actually go well above that is 60 milliamps, which is way too high. So again, check this. I would be least curious in this output circuit. Something in there. This is where most of your current goes anyway. Any of the rest of these tubes would really be a serious problem for them, especially if they're internally having a problem. They're not designed to handle anywhere near that kind of current. So I would look at this circuit here. So anyway, I hope that helps you. I mean, and make a video, let us know what you find. Not guaranteeing that the one thing, I've only really gave you one thing to look at. Not guaranteeing you that is it. There's several other possibilities but what you're looking at, and if you watch my other video that is uploading right now, I talk about circuits. What feeds these from the power supply, what's feeding all these tubes and all this circuitry, what current it's feeding it is what current comes back down through here. So if there's too much current coming back to the transformer through these resistors, that means somewhere there's too much current going. And if nothing else, you can start breaking the circuit. You can start pulling. The nice thing about this type of radio, you can start pulling tubes. You pull a tube out, you've shut that circuit down. If I pull a 6A out, A7 out, I've shut down these 3 voltages and associated circuitry with it. That has shut that down. So unless there's a short, there should not be anything going on here. So you can start pulling tubes out and keep an eye on what's going on with your current here. The minute you pull a tube out, if you start pulling some out and nothing's really, it's reducing some, but it's not really like a lot, like, a few milliamps and that's it. And then all of a sudden you pull the tube out and it just like drops really drastically, like 30 milliamps, then there's your problem right there. It may not be the tube, but it's at least in that circuit, in that part of the circuit. So, something you can do and a place to look. What I would do to isolate some of these guys out, I would just pull this 41 tube. Just go ahead and pull it. Turn the radio on, see what happens. If your current's way, way down, somewhere in the vicinity of what 7, 8, 9, 15, around 15 milliamps, 15 to 20 milliamps, then you plug that back in and it goes right back up to 60 or higher milliamps. Right there it is. So if pulling it doesn't change anything, then plug it back in, pull the next one. If that doesn't do anything, plug it back in and pull the next one. Just, you know, until you see it drastically drop. And when you see that drastic drop, there's where your problem is. Unless there's a short outside of the tube and outside the circuit. But at least then you'll know also possibly where to look. So I hope this helps you, and let us know what you find, and I'll be interested. And if you have any more questions, just, you know, email me or send me a private message or whatever, or just, you know, state something in the comments, even on this video. So anyway, I hope it helps, and thanks for watching.